Okay. Well, today's topic is about algebra. So any problems related to algebra, okay, and will be discussed here today. Some problems related to algebra. Okay. Well, what is algebra, right? Algebra, maybe cover everything, right? In elementary school, when we call pre-algebra, I look at all the contents and number theory, that they even probability, everything. So that's maybe should call the pre-math, not the pre-algebra. Algebra is usually dealing with the variables, equations, and the word problems, and those are for the algebra. Okay. So again, we emphasize the three purposes again. Number one, okay, yeah, we are going to review and improve our knowledge in mathematics, okay, and then improve our problem solving skill, okay. And number two, we are going to learn something we still haven't completely understood. And number three is, I hope you continue to improve your problem mathematical expression skill, okay? All right, so the first problem we're going to discuss is to simplify, okay, the following expression, 6x to the 2a plus b minus c. And the dot bottom has 3xa plus 2b plus 3c. Now we're trying to simplify this expression. But what we should know here is the following formula. If we have x to the alpha divided by x to the beta, then that will be x to the alpha minus beta. But if we can put in the denominator, it's going to be 1 over x to the beta minus alpha. Okay. This is the main formula. So alpha x to the alpha, x to the beta multiplied, this could be x plus beta. Okay. Right, using those two formulas, the above the expression is going to be 6 over 3 is just 2, right? Then you have x 2a plus b minus c minus a plus 2b plus 3c. So let's simplify it. Okay, so that is going to be 2a plus b, like remove the parentheses, right? 2a minus a is a, b minus 2b is negative b, and negative c minus 3c will be negative 4c. Okay, so this is the answer. Okay, now this is the answer. Okay, so this is called simplification of algebraic expressions. Okay. Now, the second problem is about system of linear equations. You have a c plus d equals 3, okay? And the d plus e equals 4. E plus c. Yeah, d plus e, e plus c. Okay, is going to be 8. So how many different variables do we have? C, D, E. Okay, 3 variables, 3 equations. Okay, we want to find out C, D, E. The product of those 3 numbers. Okay, what is a quick way to do? Okay. Yeah, what is the quickest way to do? And you can try, okay? I give you this problem. It's a system of 3 linear equations. And we want to find the value of the product of those 3 unknowns. Okay. There are many problems about that. Sometimes they ask you to find the average value of these 3 variables. Anyone can solve it? All right, so what is the quickest way is by symmetry of these equations, C plus D, D plus C, E plus C. So that's equation 1, equation 2, equation 3. We add them together, okay? So you get 2C, 2D, 2E, and that is 3 plus 4 plus 8, and that is going to be 15, okay? So C plus D plus E is going to be 15 over 2. Okay, that's it. And then it's easy to find out CDE. Okay, for example, if you want to get C, then it will be C plus D plus E minus D plus E, right? So 15 over 2 minus D plus E, it's going to be 4. Okay, so after simplified, 7 over 2. And the D, C plus D plus E minus C plus E. What is C plus E? C plus E is 8. So it's negative 1/2. Okay. Then E is a C plus D plus E minus C plus D. Okay. Minus C plus D is going to be 3. So I think it's negative. It's going to be 9 over 2. So then the product of the three numbers is just negative 7 over 2, 1/2, 9 over 2. Okay. This is how do we do. Yeah, you got three numbers and then multiply them out. Okay. Okay. My next question is, just a second. Our next problem is, okay, how many ordered integer, okay, actually integers triples which have the following property. It's not integral. I'm going to rewrite it again. Integer triples. Okay, so each ABC are integers such that each number is the product of the other two. Okay. Yeah. So you have three unknowns and you also get three questions, right? Technically. Can you get all the solutions? You're assuming A, B, C are all integers. Okay, please work on this problem. So you have to write down the 3 questions, right? You write down the 3 questions. So A equals B times C, B equals A times C, C equals A times B. So you have 3 questions and it's 3 unknowns. So sounds like you can find all the solutions, right? In general, if you have 3 questions, 3 unknowns, you can get all the solutions. Okay. The 3 questions are pretty similar. Okay. So the trick is, how do you maybe you just find multiply them out, right? A, B, C equals BC times AC times AB, and then you have a ABC square. Right, so you have this 2. Right, so there are 2 cases here, I think. So something looks like something equals something square, right? So then that X, you have 2 solutions. How to get X? So that'll be X square minus X equals 0. That is equivalent. X times X minus 1 equals 0. That equivalent. X equals 0 or X equals 1. So there are 2 cases here. So case 1, A, B, C equals 0, right? Okay. So I think if ABC is 0, then ABC, each of them must be 0. You know why? Because by the first equation, right? A equals BC implies A square equals ABC, which is 0, right? So that means A 0. Okay. So similarly, B equals 0, C equals 0. So yeah, that's only one solution. So case 2, ABC is going to be 1. Okay, if ABC is 1, then what? Then you will by the similar argument, because A equals BC, right? A equals BC. So A squared equals ABC, which is 1. So A squared is 1, that implies A is going to be plus minus 1. That's not many other choices here. Okay, and similarly, B squared equals B is going to be AC. B is AC, so you can ABC still, you can 1. So that implies B is plus minus 1. And C squared equals C. AB, right? C is AB, so C squared is C times AB, then get ABC, it's 1. So that implies C equals plus minus 1. Okay. So maximum you have 8 solutions, right? Because 2 is plus minus 1, B is plus minus 1, C is plus minus 1. But as you can see that some of the solution must be excluded because we are talking about the original equations. They say A equals BC. A equals BC. Okay. So A equals BC when A equals positive 1. Right? Then B, C is also, B times C is also positive 1. So B equals 1, C equals also 1, or A equals 1, B equals -1, C equals -1. Okay. Do you think it's possible? Because A is going to be, A is going to be B times C. So if A is positive 1, B and C must have the same sign. Okay. But then you look at this, A equals 1, B equals 1, C equals 1, then all the 3 equations hold. B is A times C, C is A times B. But let's look at here. Second one, A equals B times C, no problem. B equals A times C, no problem. C equals A times C. So I think it's correct. Okay. The second one is A equals -1. A equals -1, then B times C is going to be -1. So either B is 1, C equals -1, or B negative, positive. I think that's fine, right? Yeah, that's correct. So total, how many solutions you're going to get? You're going to get 5 solutions. Right, you're going to get 5 solutions. So you find all the solutions, okay? Okay. Now let's recall the quadratic formula: ax squared plus bx plus c equals 0. Okay, we were told that we're going to have 2 solutions in general: negative b plus minus b squared plus minus ac. Okay, so let's use this equation. Let's use this quadratic formula to find some solution. So x squared plus x minus 1 equals 0. Let's take a look at this equation, okay? So x equals 2a negative b plus minus b squared minus 4ac. Okay, so you will get 2 sets of solutions. Okay, the first one is going to be negative 1 plus minus square 5 divided by 2. The second solution is negative 1 plus square 5 divided by 2. Right. So those are the 2 real numbers, irrational numbers, okay? But those are 2 irrational numbers, those are numbers. We can estimate it if we want. Okay. So x squared plus x minus 1 can be written as x minus x1, x minus x2. Okay. Right. And so when x equals x1, you get 0. When x equals x2, equals 0. Okay. And you will see that this is going to be x. If you multiply this out, it will be x1 plus x2, x plus x1 times x2. So in other words, the sum of those 2 sum of those 2 roots is going to be negative of the coefficients. Okay. So in other words, x1 plus x2 could be negative 1. x1 times x2 should be also negative 1. And that is true. You can double check. Okay, double check. And when they add them together, yes, you get a negative 1. But when we multiply them out, let's check. Okay, x1 times x2. Okay, yeah, it's negative 1 minus 1 times positive 5 minus negative 1, right? So I think it's going to be 4 here. A squared minus b squared, a squared. Yeah, I should write it another way. So it's negative 1 squared minus a square 5 squared. Right. So you get a 1, you get negative 5. So it's negative 1. Okay, we verify this. Now what happens if I change the equation? I get this. I change the sign, plus 1. Right? Then you use the formula again. It's b squared minus 4ac. Okay. Then you will get 1 minus 4, it's negative 3. So what is your conclusion? Your conclusion is no real solutions. No solution, no real number solution. Okay. Sometimes you just simply say no solution. Now, however, if you see something it's impossible, does not mean it's absolutely impossible. Okay. If you were born 500 years ago, you also missed this problem. Then you decide to say, I'm not going to say this is nonsense. I'm going to say this has some meaning here. Okay. So let's focus on -3, square root of -3. I can do the same way. Square root of -3 is 3 times -1. It's a square 3 times square -1. I keep writing square -1. Okay. I call it imaginary number. Okay, imaginary number. We call square -1 as an imaginary number. Okay. So I simply denote by I. Okay. So if I denote by I, then -3 is going to be square 3. Square of -3 is square 3 times I. I is some imaginary number. I know I squared is going to be -1. Okay, it's hard to imagine. Okay, because we plot all the numbers along a coordinate line. That means all the numbers form a one-dimensional line. But now we have to deal with two-dimensional numbers. Okay, two-dimensional numbers. That sounds like impossible, right? Ridiculous, right? But that makes sense here because this describes the solutions. So look at go back. X equals -1 plus minus square root of 3, right? So x equals -1 plus minus square root of -3 divided by 2. I can describe it in the following way. Okay, here's a negative square root of 3 is square root of 3i. So it's kind of a, okay, so you get two solutions. Okay, another solution. Okay, it is it's minus. Okay, so those are two-dimensional numbers. Okay, those are the two-dimensional numbers in the coordinate line here. Okay, every number corresponds to a point in two-dimensional plane. Okay, I called this one I, which is imaginary axis, and this is a real number. So -1/2. Where's -1/2? Here's -1, -1/2 here, and the square of 3/2. You know, somewhere here. Okay, square of 3. So this is my x1. Okay, where's another point? Another point that will be negative square of 3/2. So it's another point is here. That's x2. Okay. Got it? So this is we call the complex plane. Okay, if we use that. Okay. X1, X2 are called complex numbers. And then any complex numbers must be in the form like that. Complex numbers one-to-one corresponds to a point in the plane. Okay, so you can use corresponding to A and B. This is the coordinates of point, right? Yeah, and then you can do the multiplication and division, and they are all okay. And yeah, for example, yeah, 2 plus 3i times 1 minus 4i. How about like that? That's, you know, you can do multiplication, and the product is still a complex number. Okay, so it's going to be 2 times 1, 2, 2 times -4i, -8i, 3 times 3i times 1, 3i. 3i times -4i will be -12. 4 times 3 times -4 is -12, and I squared, but the I squared will be replaced by -1. So then it would be positive 12 plus 2, so 14. Negative 8 plus 3 is negative 5. So you see, this is another complex number. So the product of two numbers in the plane. So every point in the plane can be viewed as a complex number. So 2 points, you can multiply them out to get another point. It's interesting, right? Then you open your eyes, you get into another world, 1 dimension high. So right now you live in 3-dimensional space. But if you can go to 4-dimensional, 5-dimensional space, you will see wonderful world. Okay, so here we just imagine, we from the coordinate line, and you add 1 dimension, you get complex numbers. Okay, we call the complex plane. Okay, I'm not going to spend too much time on complex numbers. Let's go back to the problems. Okay, so the so-called the golden mean G is a positive number that is 1 more than its reciprocal. Can you determine this number? Okay, find the G. Okay, so please go ahead to do this problem. Right, if you have answers and post it, show to me, okay? Anyone have answers for this golden mean? Golden mean. Andrew? Cool. Okay, you got it. Good idea. Okay, so first of all, write down the equation. So G is a positive number, which is 1 more than its reciprocal, right? So you get this. So you get the equation. That equation is not a linear equation. It's not any, quadratic equation at the very beginning, but you can change it. You multiply both sides by G. Then you will get, right? You will get G squared equals 1 over G, 1 plus G. Okay. So then you get an equation like that. Then just go ahead and use the quadratic formula. Okay. By the quadratic formula, -1 squared minus 4AC. Okay. So you will get 1 plus minus and the square root of 5 divided by 2. Now, so you have two solutions at the very beginning, but only one of them is positive. So you will get 1 plus square 5, and yeah, that is positive, right? Okay. Right. Sometimes we also get this is a irrational number, right? So I assume that x is going to be 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus. It's never end. Okay. So this actually is can viewed as a limit of this sequence of numbers. You know, those numbers, you know, when if you want to do computation, that will be you can count how many you know, the last one will be just only one, right? 1 plus 1 plus 1. Okay, let's see. Okay, instead of this. Okay. So you have infinite many times never be ended, all right? So you just take the limit. So how do we solve this problem? How do we get this number? So here x is viewed as the limit of sequence of fractions. Okay. So x is viewed as a limit of as the limit of a sequence of fractions. Okay. How do we solve this problem? The idea is very simple. Okay. You look at this portion. Do you think this portion is the same as this whole fraction? The answer is yes. Okay. So that means x is going to be 1 plus 1 over this part is similar to x, just x. So you get an equation like that. Okay. Then you just solve it. You multiply this out, and what do you get? You get a similar quadratic equation. Okay, similar to the equation for the golden number. So you get x squared plus x minus minus 1 equals 0. It's very similar, right? Then you solve, but you know that your x is less than 1, greater than 0. Okay, this is very important to know that. So let's solve it using quadratic equation. Okay, it still get square 5. So you get two solutions. One is -1 minus square 5 divided by 2. x2 is -1 plus square 5 divided by 2. I think clearly the second one is correct answer. The first one is negative number, so it's not going to be a solution. Okay, so the answer is x equals square 5 minus 2. Okay, let's look at this number. Is this a number larger than 1? I think larger than 2, 1/2. X is greater than equal to square 4 minus 1 divided by 2, or 2 minus 1 divided by 2, it's going to be 1/2. So this number is going to be greater than 1/2, but clearly it's less than 1. Why it's less than 1? x is going to be square root of 5 minus 1 divided by 2. It's less than square root of 9 minus 1. Square root of 9 is 3. Minus 1 divided by 2, it's 1, right? Yeah, this is between 1/2 is and 1. Okay. All right, here's the next problem. I wanted to solve it. Solve 2 to the power x minus 111, 111, okay? Times 7 times 111 to the power x. Yeah, please work on this. If you get answers and post it to me. Right now, only Andrew giving me answers. How about the other students? Okay. Kelvin, Yan, welcome. Anyone has answer now? Yeah, good. Good job. Okay. So you see, first of all, make a simple observation. 2 is just double of it, 111, right? 111. Okay, so it's going to be 2 times 111 to the power x. Okay, then you see that 2 to the x and 111 to the power x. And you will see that you can get a common fact, you can take it out. Okay, and you see that clearly this can be canceled out. Okay. So you have a 2 to the x minus 1 equals 7. 2 to the x is going to be 8. Then 8 is 2 cubed. That implies x equals 3. Okay. All right, so the next problem is an inequality problem. Solve square root x greater than x. All right, please go ahead, trying to solve it. All right, so we have to simplify it, right? Sometimes, we have to square. So here's the point. A greater than B do you think it's going to be equivalent to a squared greater than b squared? The answer is yes, if a, b are both are positive. Okay, that's a restriction. Otherwise, it's not true. Okay. Example. Okay. 2 is greater than -3. But 2 squared is less than -3 squared. You see, if one of the number is negative, and these two are not equivalent. Okay. Right, it's obvious example. So when you square both sides, you want to get equivalent equations. Then, well, even a greater than b does not imply in general, does not imply a squared greater than b squared when b is negative. Okay, so it's not equivalent. All right, so now you go back to this equation. What you can say, first of all, x cannot be negative. Okay, and x cannot be 0. It means that if x is 0, and both sides equal. All right, cool. So Kevin got answers. Okay, so first of all, you conclude that x is greater than 0. Now, once x is greater than 0, you can square it, right? Okay, first of all, we clear, and that's obvious, right? Then you can square it. Okay, once you square, you get an x greater than x squared. And since x is positive, so you can even divide by x squared on both sides. Does not change the direction we record. And then what do you get? So since x is positive, okay? So you can do that. So it's 1 greater than x. All right, so your conclusion is x is greater than 0, less than 1. Okay. All right, so let's see. Here's another problem. If x and y satisfy the following equation, 8x plus 889y equals 890, then 891 plus 892 and equals 893. Okay, anyone can have answers now, quickly? I'll give you 1 minute to think about, okay? All right. We're trying to find the, you see, find x, yeah, solve for x, find the value of x and y, yeah, find x and y of the course. That's the equation. Okay, so how do we do that? Okay, that's equation 1, equation 2. Okay, so those are two bigger numbers. Okay, so we have to, yeah, do something. Let's just do something, right? Equation 2 minus equation 1. And you're surprised, you will get an x. And let's see. Equation, you get 891 minus 888. That'd be 3x. Okay, and the difference of those two numbers, 892 minus 889, be 3y. And here is going to be 3. Okay, so now it's clear x plus y equals 1. Now, once you have this relationship, then the rest of the part is trivial. Okay, right? You get x plus y, then you can use any of the above equations to get x, right? Use any of the above equation to get x. For example, you can use the first equation, right? Yeah, you can use the second equation, first equation, doesn't matter. Okay, so let's see. You can also use a substitution like y equals 1 minus x, and you put into any of the equation. Let's say put into the second equation. So 891 x plus 892, 1 minus x equals 893. Okay, so then you will get 891x, right? And plus 892 minus 892x equals 893. And I think the difference of those two will be negative x, and this, and it's going to be 1 here, right? So that means x equals negative 1, and the y is going to be negative 1 minus x, 1 minus negative 1, and that's a 2. Okay, great. Okay, so you find the x and the y. Very simple integers. Okay. Our next problem, find the value of k for which this two following has no common solution. So that means 6x plus 4y equals 7, and kx plus 8y equals 7. This system have no common solution. Okay, so no solution, has no solution. So there's no xy satisfying both equations. Now, how do we understand this problem geometrically? Okay, so let's take a look at the equation. Okay, if you're able to simplify to this form, that means this is the slope. B is the y-intercept. So that means when x equals 0, y 0. Okay, so that's a B. Okay. So the slope, right? When x equals 0, y is b. So that's why when x equals 0, y equals b. So that's what b is called the y-intercept. Right? If you understand this, then we go back to our equation. 6x plus 4y equals 7. Right? And that equation implies 4y equals negative 6x plus 7. Y equals negative 6 over 4x plus 7 over 4. I'm going to simplify a little bit. Okay, so that's the equation. Okay, so how about this other one? Kx plus 8y equals 7. So that implies 8y equals negative kx plus 7. So then I divide both sides by 8. All right, so now we understand these two problems, 7/4, 7/8. So those two lines are not going to pass in the same point. The y-intercept is very clear. One is 4/7, which is slightly slower than that, right? 4/7 is 4/7 somewhere here. So 7/4. And the other one is 7/8. Okay, 7/8. So this equation have a negative slope, 7/4, something like that. Okay. Now the other one, we don't know because we don't know the exact value. Okay, we don't know the exact value of k. However, the solution to these two equations means there's the coordinates of the intersection point. Okay, so that means this is a y equals mx plus 7/8. So if m is not going to be negative 3/2, then there's the intersection point. If m equals negative 3/2, those two lines parallel, so no solution. Okay, so no solution means equivalent to say that those two lines are parallel, right? So equivalent to saying that the slope k/8 should be equal to negative 3/2. Okay, so then you solve the problem. Okay, that's we call the geometrical solution. Okay, we can so k equals positive, right? 3/2 times 8, it's gonna be 12. K is 12. Okay, so that is that's how do we solve the problem. Okay. So one linear equation we represent the strict lines. Okay. All right. What else we're going to talk about? All right, so let's take a look at the next problem. Okay. Find all integers x satisfies the following inequalities. Okay. X squared minus 2x less than 5. Okay. Now that is a quadratic question, right? Inequality. I know if x is very large, this left-hand side is getting a very big number. It's not going to be less than 5. So in other words, this is the equation. This inequality is equivalent to that. Okay. So we are not able to, but clearly when x equals 0 is a solution, but can I determine all the integers? Okay. So how can I do that? Well, we have to solve this equality first. Okay. So x equals 2 negative b plus minus b squared minus 4ac. Okay, so it's going to be 2 plus minus 24 over 2. I think a 24 is going to be 2 times 4 times 6, right? So square of 4 is going to be 2. Okay, so it's going to be 1 plus minus the square of 6. So there are two solutions. Okay. So what does that mean? That means if you draw the line, if you draw the graph of this is a parabola. Okay, the parabola opens upward like that, and here's 1 minus square x. This is 1 plus square x. So if we want to solve the inequality, x squared minus 2x minus 5 less than 0, that equivalent to saying that x is between 1 minus square x and the 1 plus square x. Okay. But can you determine all the integers? So you have to do estimate. Okay, you have to do the estimate. Okay. So square of 6 is a sum number. Is less than square of 9, greater than square of 4. So it's between 2 and 3. Okay. So square of 6 is between 2 and 3. Okay. So it's 1 minus square of 6 is greater than 1 minus 3, right? And less than 1, 2. So it's actually is between 2 and the negative 1. Okay. So I think you should include the negative 1, right? Inequality. But 1 plus square of 6 is greater than 1 plus 2, less than 1 plus 3. Okay. So that means this number greater than 3, less than 4. So the inequality, let's go back to this inequality. Okay. So x is integer. But that one, so that means if x is integer, x should be equal to negative 1, 0, 1, 2, I think it's 3. That's it. So you got this many integers to satisfy these inequalities. Okay, got it? Yeah, this is about inequality, quadratic equation inequality. Yeah, we probably it's brought to, I should say, some school teach that in the 9th grade, but I see, yeah, it's also required for middle school kids to solve quadratic inequalities. Okay, at least I saw the problems in the math count. Okay. All right, so let's stop here. Okay.